At the end of this topic, you will be able to define functional groups, classify the functional groups, discuss the nomenclature of alcohols, discuss the nomenclature of aldehydes, discuss the nomenclature of ketones, discuss the nomenclature of carboxylic acids. Functional groups are an atom or group of atoms or reactive part which is responsible for the characteristic properties of the compounds. The chemical properties of organic compounds are determined by the functional groups, while their physical properties are determined by the remaining part of the molecule. Examples: OH alcohol, CHO aldehyde, C double bond O ketone, COOH carboxylic acid. Based on functional groups, organic compounds are classified into the following types: alcohols, aldehydes, ketones, carboxylic acids. Alcohols. The general formula of alcohol is ROH. Here R represents the alkyl group, OH represents the functional group. Therefore, alcohols are carbon compounds containing OH group attached to alkyl group. The IUPAC name of alcohol is derived by replacing E from alkane to OL, hence we get the name alkanol. Some examples of alcohols are given in the table. Aldehydes. The general formula of aldehydes is R, CHO, where R is an alkyl group or hydrogen atom and CHO is the functional group. Aldehydes are carbon compounds containing CHO group are attached to alkyl group or hydrogen atom. The IUPAC name of aldehyde is derived by replacing E in the word alkane by the suffix Al, hence we get the name alkanil. Some examples of aldehydes are given in the table. Ketones. The general formula of ketone is RCOR, where R and R are alkyl groups and CO is the functional group. Ketones are carbon compounds containing carbonyl CO group attached to two alkyl groups. The IUPAC name of ketone is derived by replacing E in the word alkane by the suffix ONE. Hence, we get the name alkanone. Some examples of ketones are given in the table. Carboxylic acids. The general formula of acid is RCOOH, where R is a hydrogen atom or alkyl group and COOH is the functional group. Carboxylic acids are carbon compounds containing COOH group attached to a hydrogen atom or alkyl group. The IUPAC name of acid is derived by replacing E in the word alkane by the suffix OIC, acid. Hence we get the name alkanoic acid. Some examples of carboxylic acids are given in the table.
In this topic, you have learnt
functional groups are an atom or group of atoms or reactive part which is responsible for the characteristic properties of the compounds. The functional group of alcohol, OH, aldehyde, CHO, ketone, C double bond O, carboxylic acid, COOH. The general formula of alcohol, ROH, aldehyde, RCHO, ketone, ROR, carboxylic acid, RCOOH. At the end of this topic, you will be able to explain the manufactures of ethanol from molasses, list the uses of ethanol, define esterification, recall the test for the identification of alcohol, explain the physical properties of ethanol, discuss the evil effects of consuming alcohol. Ethanol or ethyl alcohol is one of the most important members of the family of alcohols. Its molecular formula is C2H5OH. Molasses is a dark-colored syrupy liquid left after the crystallization of sugar from the concentrated sugarcane juice. Molasses still contains about 30% of sucrose which cannot be separated by crystallization. Ethanol is manufactured from molasses by the following steps: dilution, addition of ammonium salts, addition of yeast, distillation. Dilution. Molasses is first diluted with water to bring down the concentration of sugar to about 8 to 10%. Addition of ammonium salts. Molasses usually contains enough nitrogenous matter to act as food for yeast during fermentation. If the nitrogen content of the molasses is poor, it may be stimulated by the addition of ammonium sulfate or ammonium phosphate. The solution from step 2 is collected in large fermentation tanks and yeast is added to it. The mixture is kept at about 303 K for a few days. During this period, the enzymes invertase and zymase present in yeast bring about the conversion of sucrose into ethanol. The fermented liquid containing 15 to 18% alcohol and the rest of the water is now subjected to fractional distillation. The main fraction drawn is an aqueous solution of ethanol which contains 95.5% of ethanol and 4.5% of water. This is called rectified spirit. This mixture is then heated under reflux over quicklime for about 5 to 6 hours and then allowed to stand for 12 hours. On distillation of this mixture, pure alcohol 100% is obtained. This is called absolute alcohol. The overall reaction is C12H22O11 plus H2O gives C6H12O6 plus 6 C6H12O6. C6H12O6 gives 2C2H5OH plus 2CO2. The slow chemical change taking place in an organic compound by the action of enzymes leading to the formation of smaller molecules is called fermentation. Ethanol is a clear liquid with burning taste. Its boiling point is 351.5 K, which is higher than corresponding alkane. It is completely miscible with water in all proportions. Dehydration. Intramolecular dehydration, ethanol when heated with excess concentrated H2SO4 at 443 K undergoes intramolecular dehydration, that is, removal of water within a molecule of ethanol forms ethane. Intermolecular dehydration. When excess of alcohol is heated with concentrated H2SO4 at 413 K, two molecules condense by losing a molecule of water to form ether, that is, removal of water from two molecules of ethanol forms diethyl ether. Reaction with sodium. Ethanol reacts with sodium metal to form sodium ethoxide and hydrogen gas. Oxidation. Ethanol is oxidized to ethanoic acid with alkaline KMNO4 or acidified K2Cr2O7. During this reaction, orange color of K2Cr2O7 changes to green. Therefore, this reaction can be used for the identification of alcohols. Esterification. Ethanol reacts with ethanoic acid in the presence of concentrated H2SO4 catalyst to form ethyl ethanoate and water. The compound formed by the reaction of an alcohol with carboxylic acid is known as ester, fruity smelling compound, and the reaction is called esterification. When the vapor of ethanol is passed over reduced copper catalyst at 573 K, it is dehydrogenated acetaldehyde. Uses of ethanol. It is used as an antifreeze in automobile radiators. It is used as a preservative for biological specimens. It is used as an antiseptic to sterilize wounds in hospitals. It is used as a solvent for drugs, oil, fats, perfumes, dyes, etc. It is used in the preparation of methylated spirit, rectified spirit, power alcohol, and denatured spirit. It is used in cough and digestive syrups. Evil effects of consuming alcohol. If ethanol is consumed, it tends to slow down metabolism of our body and depresses the central nervous system. It causes mental depression and emotional disorder. It affects our health by causing ulcer, high blood pressure, cancer, brain and liver damage. Nearly 40% accidents are due to drunken drive. Unlike ethanol, intake of methanol is very small quantities can cause death. Methanol is oxidized to methanol formaldehyde in the liver, and methanol reacts rapidly with the components of cells. Methanol causes the protoplasm to get coagulated in the same way an egg is coagulated by cooking. Methanol also affects the optic nerve, causing blindness.
In this topic, you have learnt
Ethanol is manufactured from molasses, an aqueous solution of ethanol which contains 95.5% of ethanol and 4.5% of water is called rectified spirit. The slow chemical change taking place in an organic compound by an action of enzymes leading to the formation of smaller molecules is called fermentation. Ethanol is oxidized to ethanoic acid with alkaline KMNO4 or acidified K2Cr2O7. This reaction can be used for the identification of alcohols. The compound formed by the reaction of an alcohol with carboxylic acid is known as ester, and the reaction is called esterification. Ethanol is used in cough and digestive syrups. Nearly 40% accidents are due to drunken drive. At the end of this topic, you will be able to write the method of preparation of ethanoic acid, give the physical properties of ethanoic acid, write the various reactions of ethanoic acid, state the uses of ethanoic acid. Ethanoic acid is commonly known as acetic acid. Acetic acid belongs to the group called carboxylic acids. It is present in many fruits. The sour taste of fruits is due to acid. Preparation of ethanoic acid. Ethanol on oxidation in the presence of alkaline potassium permanganate or acidified potassium dichromate gives ethanoic acid. Physical properties of ethanoic acid. It is a colorless liquid. It has sour taste. It is miscible with water in all proportions. It has boiling point 391 K, higher than corresponding alcohols, aldehydes and ketones. On cooling, pure ethanoic acid is frozen to form ice-like flakes. They look like glaciers, so it is called glacial acetic acid. The chemical properties of ethanoic acid are as follows. Ethanoic acid is a weak acid, but it turns blue litmus to red. Reaction with metal. Ethanoic acid reacts with metals like Na, K, Zn, etc. to form metal ethanoate and hydrogen gas. Ethanoic acid reacts with carbonates and bicarbonates and produces brisk effervescence due to the evolution of carbon dioxide. Ethanoic acid reacts with sodium hydroxide to form sodium ethanoate and water. When sodium salt of ethanoic acid is heated with soda lime, solid mixture of 3 parts of NaOH and 1 part of CaO, methane gas is formed. Ethanoic acid is used for making vinegar, which is used as a preservative in food and fruit juices. Ethanoic acid is used as a laboratory reagent. Ethanoic acid is used for coagulating rubber from latex. Ethanoic acid is used in the preparation of dyes, perfumes, and medicine. In this topic, you have learned ethanoic acid is otherwise called as a glacial acetic acid. Ethanoic acid is used in the preparation of dyes, perfumes, and medicine. On cooling, pure ethanoic acid is frozen to form ice-like flakes. Ethanol on oxidation gives ethanoic acid. Ethanoic acid is a weak acid, but it turns blue litmus to red.